So this is the Tinkercad simulation of our solar tracker what we are making. So these are the two servo motors that we are using, one for the horizontal axis rotation and the other one for the vertical axis rotation. And this is an Arduino Uno board, and here we have four LDRs, and here we have four 10 kilo ohm resistors. Let us see the connections. Let us zoom in a bit. We are using 4 LDRs to sense that the light intensity is maximum in which direction. Is it in the above plane, or it is in a plane which is sidewise to it. So here we are taking the LDR inputs in 4 analog pins, and according to that we are rotating our servo motors which are attached to the pin 9 and 10, which are digital pins. And so let us see the simulation and then we can go for the code. As we can see, if we virtually increase the light intensity over here, we can see that the motor has started rotating. Let us decrease it back to 0. And again, if we increase this one, we can see both of them are rotating. Let us bring it back to 0 again. Now let us increase this one. We can see that this one is rotating in this direction and this one in the opposite direction. And why is it so? Because this one is the horizontal servo motor and this one is the vertical servo motor. And let us see the last LDR, what happens. Both of them are trying to return to their positions. So that was it. And let us see the code over here. So here we have defined two servo motors, one for vertical and one for horizontal. We have taken the 4 LDR inputs, and then we programmed for the top left, top bottom, top right, bottom left, bottom right. And then accordingly we have seen, first we have checked for the top and bottom, and then for the left and right, and accordingly we have changed the angle of the servo motors. And that was it. Now let us jump into the real model. This is the model of our dual axis solar tracker. As you can see, here is the power input where we have to give the power, and you must be curious that what is inside this white box. So I will explain that first and then I will come to the model. This is what is there inside the white box. This is a detailed of everything what is there inside it. So this one is the Arduino Uno board. It is there inside the white box. And one of the servo motors, as you can see over here, is also attached inside the white box, and one of the servo motors is outside it. These are the 4 LDRs, and the change that I have made is, here the 4 LDRs are attached in a cardboard. I have just put them in a Vero board and used a divider so that the light coming from one direction does not affect the other LDR. So I have put that divider. And here you can see 8 wires are coming from these 4 LDRs, and the analog signals are taken to the analog pins of the Arduino. And here are the 4 10 kilo ohm resistors which are there to control the amount of current flowing through the photoresistor. A huge excess current may burn a LDR or a photoresistor. And here at the digital pins, the signal line over here for the servo motors are attached at 9 and 10. And so that's it. Now let us get back to the model. Now I will try to show you the details of the model. if you see closely over here, here I have a Vero board where the 4 LDRs are embedded, and there are 4 10 kilo ohm resistors which are in series with the LDRs, and with that we have a solar panel attached with it, so that the LDR can sense the maximum intensity direction and rotate the solar panel accordingly. Here we have one of the servo motors which rotates the solar panel in the north and south direction, and one of the servo motors is inside the white box on which this one is pasted, and this one helps in the rotation in the east and west direction. So in all we have one solar panel, 4 LDRs, 4 10 kilo ohm resistors, few wires, 2 servo motors, and one Arduino Uno which is inside this white box. Now I will try to demonstrate our model. I will power this up with the data cable. As you can see, the initial flick, which is due to the code that we have written. In the code we have given an initial angle of 20 degrees, so it gave an initial quick flick, but after this it will be gradually moving according to the light direction. Let us check it out. Yeah, so this is perfectly working.